Hello, geometry students. Welcome to our first notes. They are titled Notes 1-1, Basic Geometry Vocab. Let me remind you that as you go through these notes, you need to make sure that your notes look exactly like my notes. Everything that I write down, you write down. Rewind, pause if necessary to make sure you get all this stuff. Okay, all the flips that we've put inside of our journal, we see that these are the ways that geometry is written down, and we're going to give the word, we're going to describe it a little bit, and then we're going to flip it up and give a description and notation. So the first word that we have here is a point. A point is written by a dot, and there's always a letter next to the point. I'm going to put a B. All right, and if we flip that up, the way that points are always written are just by the letter. So this is going to be point B. The definition, well, there is no definition. A point in geometry is an undefined term. There's no definition to a point. It is simply a location. All right. Our next flip is a line. And on a line, you're going to see several things. At one end of it, you might see a lowercase cursive letter, so I'll put a cursive M. But then on that line, we know that a line has to be made up of 2 points. So I'm going to put the letters A, the letter B. When I flip up this thing, we can notate this one of a couple ways. I can call this line AB, and so I can put an AB with my line over top, or this can be line BA with my line over top, or we could write it out and say this is line M. One of those 3 ways would be correct. A line is also another undefined term in geometry. Okay, but a couple characteristics: it has at least 2 points, and it has infinite length. It goes infinitely in both directions. Our next flip is written there with a cursive R. This is a plane. All right, on top of our plane, there might be some other points. Remember, we need 3 points to make a plane, so I'm going to put point A, point B, and point C. These 3 points need to be non-collinear. All right, we can call this, then, by its capital cursive letter, plane R, or by the 3 points, any 3 points on that plane, so plane ABC. All right, and a plane is our last undefined term in geometry. Has no definition. Some characteristics: it must contain at least 3 points. And it also extends infinitely in all directions. Our next term is a segment. At the end of each segment are points. I'm going to label these points C and D. When we flip this up, then, I can notate this, and then the notation is how you can write it out. So if you're writing out this is segment CD, there will just be a line over top. Notice no arrows, signifying that it has a beginning and it has an end. And a segment has length. Unlike a line, there is a beginning, there's an end, so it has length. There are 2 points, and all points in between. Our next term is array. There's always a starting point to array. I can label this point G, and it's going to go through, I'll say N. It doesn't really matter what the points are, but it is very specific how you can notate array. If I have this is only ray GN, and we have to start with G and go through N. It is not ray NG because that would go the other direction. We have to start at G and go through N. Array is simply just part of a line. It has one endpoint and it goes infinitely in the other direction. goes infinite in other direction. Our next term is an angle. I'm sure you've seen this before. On my angle, I have several things. I can have a number inside of my angle, or I can have points around my angle. All right, I'm going to label my angle angle B, C, D. So when I flip this up, there are 3 different ways I can notate this angle. One way is just by the number inside, if it has one. So I'm going to say this is angle 1. There's a symbol for an angle. It's not an L, that's an angle symbol. So angle 1, or angle LMN, or, I'm sorry, I have different letters, angle BCD. Let's try that. Angle BCD. Or the other direction, then I could go angle DCB. All right, an angle has one vertex, and the sides are made up of 2 rays. So 2 rays are the sides. My next flip here looks like I have a line, but this is actually the definition of the symbol, or I'm sorry, it is a picture of collinear. Collinear, there's no way to notate it. It is just simply points on the same line. All right, the next word here is coplanar. All right, coplanar would be if we have points, lines, or rays on the same plane. And that could be any of those, so it could be a point and a line, could be a coplanar together, or a couple points or a couple lines, any mix of those. The next things, you've probably seen these before, different types of angles. You could write these in. So the first angle is an acute angle. Then we have a right angle. Then we have an obtuse angle. And we have a straight angle. And again, I'm sure you've seen these before, so we should know what they signify. An acute angle is less than 90 degrees. A right angle equals 90 degrees. An obtuse angle is greater than 90 degrees, and this is the greater than or less than symbol. And then a straight angle would be 2 90-degree angles put together. That equals 180 degrees. Our next picture here is of parallel lines. And you can see that on these lines there is a symbol for that. There's 2 arrows going the same direction. Okay? I'm going to label these lines P and line T. And so the way that I can notate this underneath, if I have line P is parallel to line T. 2 slanted lines means parallel. And the definition are lines that never intersect. All right, our next picture is of perpendicular lines. I'm going to label these lines G and line H. All right, so line G is perpendicular to line H. The notation for that is an upside down T. Definition then are lines that intersect to form right angles. Not just intersect, but they form right angles. Next thing, I showed this in class. This is an example of skew lines. And skew lines are lines that are not parallel and they do not intersect. So the way that we would have to have this, or these 2 lines would have to be in 3-dimensional. And so we've got one line going one direction, another line going in another direction, and they're never going to touch because they're not on the same plane. So we could say those lines are non-coplanar. All right, next one, a couple new things for us. These 2 angles, angle 1 and angle 2, are called adjacent angles. Adjacent angles are when we have two angles that are right next to each other and they share this ray right here. So the way I can describe these are two angles with a common vertex vertex is a starting point, and a common side. All right. If we look at this, these two angles are next to each other. So if you remember that adjacent angles are next to each other. Kind of like if you are out in a classroom right next to somebody else, you're in adjacent classrooms. Next here, it's describing this bold line or bold ray here. This bold ray is an angle bisector. Okay, it's being bisected because I know the symbol right here. These two symbols stand for something. They mean congruent. So angle 1 is congruent to angle 2 if they're written on angles like that. There is a way to notate this, in this case, that angle 1 is congruent to, here's a new symbol, it's an equal sign with a squiggle on top. Angle 1 is congruent to angle 2. So I'm going to write that down. That word, that symbol means congruent. If I'm talking about the measure of these angles, the measure of the angles is the exact same. So the measure of angle 1 is equal to the measure of angle 2. Okay? The definition then of an angle bisector is a ray that splits an angle into two congruent adjacent angles. A ray that splits an angle into two congruent, there's a symbol, congruent adjacent. There's also a symbol for angles. It is an angle symbol with an S in the middle of it. So I can abbreviate there. The last term that we have is on a segment with a point in the middle. I've got two segments that split into, and this is called defining a midpoint. It's showing us a midpoint. If I have segment AB, the whole entire thing, and point M is in the middle, M is a midpoint. I know this because of the symbols that are written down. This little symbol here and this little symbol here means these segments are congruent. So I can notate underneath that segment AM and segment MB are congruent with the midpoint. So AM segment is congruent to MB. It's also a segment. So the definition of midpoint is a point that divides a segment into two congruent segments. Point that divides a segment into two congruent segments. And it's right in the middle. Point M is right in the middle of my segment AB. Okay, make sure you get all those notes. Bring your notes to class. Always have your notebook in class. And I'll see you guys later. Have a great day.